Alright, so we got a basic extruded component here. And the aim that was to use this component twice over within an assembly to create a hinge and a retainer. So just looking at the single individual component by itself, you can almost see how we could manipulate such an assembly to use just one component to have an encasing. We're going to see from the 3D print a little bit later on how that all works out, but some of the improvements that we can make on this design to make it more effective to what we want it to do based on the printout is, well, firstly let me speak about the print, and then we'll speak about how this would be injection molded and some of the considerations that we need to take into account when we're injection molding. So looking at this component as it is drawn right now and how it's come out on a 3D printer, one aspect that needs to be added to this design is you could almost add a detail tangentially over here, a return, or maybe even fill out this material here where we've got the snap detail in the hinge, because that's going to allow us to unhinge and uncouple when we go to the other side. Now this is going to make a little bit more sense when we go into the assembly, but for the purposes of this part of the exercise, we'll just look at this as an individual component. The tolerance between here, this mating face and this mating face here could have been tightened up, so I think we could probably run about half of what we got. We got about mil tolerance on both sides, but we could probably go about half within that. Another thing to consider is the distance of this snap ball hinge component. This is kind of doing two things. Yes, it is snapping to make a retainer, but also it is the axis for this hinge to open with. Okay, so you can see this is, I've drawn this, and I've drawn the sphere halfway through this mating face. Now we could really push that in a little bit. That'll give us a little bit more tolerance, but I think it works well enough, as you'll see within the demonstration. I think it works well enough. I think really all we need is to increase this material, maybe just a mil or so, or if we're considering injection molding, since this is just a prototype component, what we might do is we might choose a material that gives us enough flexibility to achieve what we wanted to do by just adding tags there, which when I played around with this after it's been printed, you can see it works reasonably well, with the exception of adding some tags. Another little improvement that we can have is we could run a return one of these faces, but remember we're using the same component to create a case, right? We have to be strategic on where we put a return on the inside, so that when the assembly is made up, you've got a mating face on the inside that stops the box from rocking to and fro. Now you could really just put that over here, and you'll see when we go into the assembly how that would work. Okay, so things to consider when injection molding: probably need a couple of draft angles on the inside. This first extruder we can see here, that could probably be drafted out before we shell it. And then also too, there's a lot of material here that's not material thickness, so that's going to need coring out. Right, that needs to get cut. So you can see I've cored out this to be material thickness, which is about 3 mil if I remember correctly how I've drawn it up. So we've not got a lot of material in here as such. But if I was gonna get this tooled out, I'll be thinking about cutting this and coring it out. So we've got the attachment points, but also too we haven't got that thick buildup of material where you end up with sink marks on here and potentially some warpage along this face, just given how much heat is in there going through that part. I think the same thing applies for this side, of which you can see I already cored a part of that. Probably go in further and core that a lot. Think about it cooling. We've got a lot of material that's attached to this face here, and that's just going to cool at a different rate to that face. Okay. So now that we've looked at the component in its individual state, what we could do now is we can look at how the model is intended to work. Just hide off these planes for the time being. So if I was to go to here and hide these construction planes off, Now expand this component. You can't see this on the other screen because I've just showed you what we're demonstrating here. So you see it works pretty well on the screen, and it does work in reality pretty well. You can see it just snaps in there, and those interference faces, remember, because we've got this gap in between here, those interference faces, with the addition of this tags, if I was going to be improving this design, then those mating faces are going to snap into locking position. And this, the beauty of this design is we can open this from any direction. That was the intention, that was the goal. Very simple model, but a little bit of thinking, you could take something very simple and make it quite smart, if you don't mind me saying. So we've got the same hinge mechanism on the other side because it's the same component rotated round over its around over onto its face, lifted up and rotated 90 degrees about the y-axis. Okay, so you see it's the same component. We're just looking at the same component rotated round, and you can see how this design works. So I can open this. I haven't modeled it to open in both directions, but this in reality can open in both ways, and both faces, or both hinge mechanisms, act as the retainer to the other side, which I think is pretty cool. So I'll probably look at this design in the future. I won't do another video on it, but I'll probably look at this design in the future and make those refinements that we've spoken about. Put a little tag over here, but then remember, whatever we do to one face, we're doing to the other face, okay, because it's the same component. So we probably have to think about putting one tag over here, which ends up being over here. Nothing that would work pretty nicely. So that'll become a means of making sure that the assembly doesn't rock, which when you see the model once it's been printed, it does rock a little bit, but it's pretty good for what we want to do with this exercise. Okay, so that's the first snap fit design in this. Hopefully it's going to be an ongoing series that we're going to do, looking at snap fits. Again, these are pretty clever means of retaining and doing all kind of cool things and so on and so forth. Okay, so I hope you enjoyed the video. Watch the clips, and I'll see you on the next one. Goodbye. Another idea that comes to mind in improving this design is you could probably have some tabs over here to bring these snap joints in from here. So that's going to help us open and close. You can see it opens quite nicely. And again, like I said in the previous excerpt, if I was to open it from the other side, you would probably want some tabs underneath or just a little bit of overhang to bring that snap joint in, and you can open it from the other side. But considering I just eyeballs this, I'm pretty happy with how it's come out. Let's close it up. It's open now. Put it in retainer mode. There you go. Pretty nice. Right, so you can see this is now printed, and it's printed out reasonably well on my CC2. When we looked in the CAD, we saw the hinge mechanism is also the snap retainer, and we can see that works really well as a hinge. There, that works really damn well. You can see, I can pull this up, I can swing it, it's not coming out. When we close this, it snaps really nicely into place. You gotta bear with me there. Trying to do this with one hand is not the best. You can see it's closed, and that's all one part. So areas of improvement, if we're gonna print this out again, we're probably gonna give us a bit more tolerance in between these gaps here, and that's gonna give us the ability to open it from both directions, because you can see I've snapped one of these already. I've snapped one of these already, so that probably wants to be thicker. Maybe 5 mil. It's 3 mil at the minute. Maybe 5 mil. Make it a little bit better, but it also needs to be flexible, because remember, not only is this the hinge, but it's also the retainer on both sides. So when this works, which I might jump into this, make a miniature version of it in the future sometime. I won't make a video on it, but when it works the next time, you'll see it opens in both directions, if that makes sense. So it's hinged both ways. But remember, this is the same part. So it's a little clever design here. A little smart idea, if I may say so. It's a real smart idea. I can see the application of this in a maybe an electrical connector cover or something like that, a junction box where you can have access both sides. And again, like I said, remember this hinge system, this is the same hinge system as that side, so you can open this from this way and it hinges the other direction. Pretty cool. Simple but effective.